Hello everyone, thanks for tuning in. My name is Arnold. So in today's video, I am covering a question as you're seeing on your screen. I'm going to talk about this it's a past paper question on quantitative techniques. Now, of course, as I am doing these questions, my assumption is that you have studied these topics in class. These topics have been adequately introduced to you in class. So explain the term stratified sampling and give its 3 advantages of stratified sampling. Basically, these kinds of questions, I'm just going to explain the concept of stratified sampling, and then when you understand it, you should be able to come up with your own words to explain what it is. Okay. So now let's assume right here, right now. I'm going to assume that we have something called, let's say, let me just draw this box to illustrate. This is a school, okay? That is a school, and in this school we have classes where we have senior 1, we have students of senior 2, senior 3, senior 4. The students in senior 1 are 100, the students in senior 2 are 200, maybe the students in senior 3 are 400, the students in senior 4 are 600. I'm just coming up with arbitrary figures just like that. So let's say we want to find out how many people here, okay, in this school. We want to make an analysis on maybe the most popular phone brand, okay? You know, there are various phone brands. There is the Android phone, okay? Then there is the iPhone, okay? The ones that have the iPhone and Android. And we want to find out which ones of these 2 phones, which we want to make a statistical analysis to find out which one is more popular amongst these students. So we can go ahead and just pick. It means these are how many? These are like 1,300 students in total. Okay, but then we cannot go and analyze or pick information on all the 1,300 students. There might be too many for us to do so. It could become too expensive or very time consuming. So what we do is that we are going to do sampling. Okay, we are going to sample from these 1,300. We are going to get what we call a representative portion of these 1,300 students, so that we are able to find, you know, we get a sample from this population. Okay, it's a population of 1,300 students, but what we are going to do is that we are going to get a sample from there, and it is from that sample that we are going to go and make our statistical analysis on that sample. Now, what happens is that the way stratified sampling works is that we are going to divide this population into its distinctive characteristics. So here I just gave an example of a school, and we know that in a school we have senior 1s, we have senior 2s, we have senior 3s, we have senior 4s. So this is how we have chosen to divide this population into those 4 segments according to their classes. So because we have divided these classes into their 4 segments, these 4 segments that we have divided these classes are what we are calling strata. Okay, and this is where the term stratified sampling comes from. Remember, the question is asking us to explain stratified, okay, stratified sampling, and we get explain stratified sampling and give 3 advantages of them. So that is what we do. Okay, so they are called strata. Okay, so here the strata is just based in terms of the classes. We have divided them in terms of their classes. Now maybe we can choose to divide this population in terms of maybe where they come from. Maybe of this population of 1,300, there are those that come from the northern part of the country, from the south, okay, from the east, from the west, from the central. something like that. So it means that you have divided your population in that. So in other words, the method you use depends on you what you think is applicable for you. So for this case, we've divided them in forms of classes. So what happens after dividing the population in terms of classes like you're seeing here, then we shall go and pick from each strata, we shall pick a sample from each strata that is representative of that unit. So for example, here, the senior ones are 100. So we can say we are going to pick 10. I'm just giving an example, 10 students from senior 1. Senior 2, they are 200. So we shall pick 20 students from here. Senior 3, they are 400 students. So we shall pick 40. Senior 4, they are 600. From here, we shall pick 60 students. So do you realize that in each strata, I just picked 10% of the population of that strata? Okay, so and how do I pick those 10%? I can just come and pick them at random. Yeah, 20, I just come and pick them at random. The 40, I know these are 400 students. I'm going to pick 10% of that. So I just come and pick them at random, like that. So I go and get these samples that I have picked, and now those ones become all together are the ones that I'm going to analyze on, they are representative of the entire population. And so I'll go ahead and do my statistical analysis like that. So this is basically what is called stratified sampling. That is what we call stratified sampling. And I've explained it using diagrams. So looking at how I've explained it, you can use your own words to explain the term stratified sampling, okay, using your own English, and give it 3 advantages. So if I'm meant to use it in my own words, I could just simply say that stratified sampling is simply a sampling technique that is used in statistics and research to ensure that the sample is selected from a population, or a sample that is selected from a population represents various subgroups or strata, okay? So various subgroups or strata within that population. So like I've illustrated the population of students, and we subdivided it into groups, okay? So we can continue and say that it serves to accurately reflect the characteristics and proportions of the entire population. I can go ahead and explain further that in stratified sampling, the population is first divided into distinct non-overlapping subgroups or strata based on certain characteristics or variables of interest. So the characteristics of variables of interest depend on you. In our illustration, we used classes. You can use tribe. The subgroups can be based on the tribe, maybe the region where they come from, the country, or the subgroups can be based on gender or based on, whatever characteristic you choose, okay? And these variables can be factors, okay? Like gender, income, geographical location, or any other relevant criteria. And each subgroup should be internally homogeneous. And of course, by internally homogeneous, we mean that the individuals within the subgroups should be sharing similar characteristics. That's what we mean by them being internally homogeneous. So once the population is divided into the strata, a sample is selected independently from each stratum, and an appropriate sampling technique like random sampling or systematic sampling is used to get the samples from each strata. And the sample size from each strata is proportional to the size or importance of the stratum, like we had already done here, that each sampling size, okay, each sample that we picked here is proportional. So we say 10% of each, and you realize that the numbers here, where there were 10, here there were 40, here there were 60, and so forth. So that is it, that this ensures that each stratum contributes to the overall sample in the population, and it's representative. So the explanation I'm giving you here is general. You just have to understand the whole concept. You can always use your own sentence constructions in the exam to explain this Yeah, something like that. So of course it goes on to say and give 3 advantages. Of course, let's get started with the advantages. The first one, of course, there is increased precision and accuracy of the statistical estimates. Why do we say that there is an increased accuracy? Of course, this is because this is when there is considerable variability in the population. Representation from each stratum helps to eliminate sampling error, which leads to reliable results, okay? So rather than getting into this population and then we just come and pick at random, okay? If we divide them in groups of similar characteristics and then we come and pick from each group, it's going to increase the precision and accuracy of our results. So in other words, this has to do with the results, okay? Our results are reliable at the end of the day. Reliable results, okay? Or call it increased precision. Okay, the second advantage here is, of course, adequate representation, okay? We have adequate representation of the entire population because, yes, we have divided it into subgroups and each group has been represented in the sample. So by selecting samples from each stratum proportionally to its size or importance, the resulting sample reflects the diversity and distribution of the population. So the sample is well represented. Okay, and this enables easy drawing of conclusions and generalizations regarding the entire population. Okay, then of course also the third issue is eliminates sampling bias. Okay, it eliminates sampling bias. In other words, it helps to mitigate the potential for sampling bias, okay? Because we eliminate issues of maybe one, for example here, if we're saying that we are getting each class 10%, we are getting 10% from each class, it means that each class is adequately represented. There is no class that has been overrepresented, there is no class that has been underrepresented. So it means that our results will be free from sampling bias. So in other words, if you're to write, you can say that it helps mitigate the potential for sampling bias. Sampling bias happens when certain characteristics or groups in the population are either overrepresented or underrepresented, and this leads to distorted results. Stratified sampling, however, ensures that each subgroup is adequately represented, therefore reducing chances of producing biased estimates, thereby producing a more representative estimate. Okay, so basically that's it. So those are your 4 marks. We have finished with question 1A. So now let's get to question 1B. So question 1B is more of a calculation statistical question. They're telling us here that 2 students, Elijah and Eliot, sat for business law and quantitative techniques and taxation exams in 2021. So we have business law here, quantitative techniques and taxation exams. The table below shows their marks and weights attached to each mark. So as you can see, there it is. It's showing their marks. So they're asking us in Roman 1 here, determine the value of x. The value of x is right here. The value of x for which Elijah and Eliot's examination marks have the same weighted mean. Okay, there is the thing we call just mean. Okay, then we have it when it is weighted. Okay, I'm not going to explain the difference between these two. By the time we're doing these revision classes, my assumption is that you have covered these things have been introduced to you comprehensively by your teacher. Here we're just doing revision. So you're not just doing mean, which is the summation of the total amount out of the number of items. We are looking at weighted mean. In other words, a weight has been applied to each of the items So it means that the total weight, the weighted mean, let me write the formula here. The weighted mean is given by the summation of the weight times the value of x. Okay, in this case, okay, this is our weight. No, this is what we are calling our weight, and now the value of x are these, the max. Okay, the max. So it is w times x, divide that by the total weight. Yeah. How does this formula come to be? I'm not going to go into those details now. We will be explaining those things when we are doing the topical based videos, when we are explaining you know, when we are doing the syllabus videos. These are just revision series. Okay, so let's get started. So they are telling us to determine the value of x for which Elijah and Eliot's examination marks have the same weighted mean. So they want the value of x for which the weighted mean for Elijah and for Eliot are the same. So if they are the same, so the overall picture here is that we're going to get Elijah's weighted mean. Okay, then we are going to get Eliot's weighted mean. Now, because they are the same, we are going to equate them, and when we are equating them, we shall get the value of x. As simple as that. So let's get started with the weighted mean. This is now, let's call this one the weighted mean for Elijah. Okay, the weighted mean for Elijah is the summation of the weight times x. Okay, the x here is the variable. Okay, in the variable in this case are the marks. Okay, because we are looking at marks of each of these people. So in this case here, it's going to be the summation of the weight. So we shall begin weight. We remember we're looking for Elijah, so we are looking at this here. These are the value of x we are going to be looking at for Elijah. Okay, so for Elijah, it's going to be the weight, which here it is 2 times 80. 2 times 80 plus, then we have x times 72x times 72 plus, then we have 3 times 46. 3 times 46 right there. Divide all that by the total weights. Now the total weights is this plus that plus that. Okay, it is the weight which is 2 plus x plus 3, like that. And then what do we have there? Of course, 2 times 80 is going to be 160. Then this is plus 72x plus 138. Divide that by 2 plus 3, which is 5, plus x right there. So what do we have there? Of course, what we have there as our final thing here, it's going to become, we shall just simply end up with 298. When we add 160 plus that, is going to be 298 plus 72x. Divide that by 5 plus x. That is as far as Elijah is concerned. Okay, so now that we are done with Elijah, let's do the one for Eliot. Okay, let me use a different color for that. Eliot weighted mean. Eliot's weighted mean is still going to be the summation of w times x over the total weights. Again, for Eliot, now we are looking at Eliot, and we are looking at Eliot. We are going to look at that's our values of x for Eliot. So again, it's going to be 2, the weight, it is 2 times 64, 2 times 64, plus, we are going to get x times 82, that is going to be 82 times x, or x times 82, whatever the order, plus 3 times 40, yeah, 3 times 40, divide that by the total weights, which is definitely the same, which is 2 plus x plus 3. So this is going to be 2 plus x plus 3. Of course, 2 times 64 is going to give us 128 plus 82x, right? Okay, something like that. 82x plus 120. 120 is 3 times 40, which is 120. Divide that by, that is 5 plus x. Okay, so from there, it's going to become, definitely the whole thing is going to become 200. When we add the 2, it's going to be 248 plus 82x, divide that by 5 plus x. Okay, so this is the expression we have for Eliot's weighted mean, and that's the expression we have for Elijah's weighted mean. But remember, they're telling us the question as that determine the value of x for which Elijah and Eliot's examination marks have the same weighted mean. So if they're having the same weighted mean, it means that this expression here is the same as that expression here. In other words, they have the same weighted mean. So that is what we're going to do next down here. So we know that Elijah's weighted mean is the same as, or it is equal to, Eliot's weighted mean. And we know that Elijah's weighted mean, the expression is 298 plus 72x, divide that by 5, plus x is equal to 248 plus 82x, divide that by 5 plus x. So now our role here is to go ahead and find the value of x. Okay, so what is remaining here are just now your algebra skills. So let's eliminate, since the denominators, okay, you can either cross multiply, or since you multiply 5 plus x on both sides, whichever way you find easier for you. So let me multiply 5 plus x on both sides to, like that, 5 plus x on both sides. You know the effect is the same. This goes with that, then this will go with that. Yeah, then we shall come here, we end up with 298 plus 72x is equal to 248 plus 82x. Now the previous step, you can also cross multiply, you will still arrive at the same answer. Okay, so let's collect like terms. This is going to be 72x on this side, then this thing is going to come that way. It is positive 82x. When it crosses the equal signs here, it becomes negative 82x. So I shall say minus 82x is going to be equal to, this is 248. That is what has remained here. Just 248, not just 248x. So it's 248. Let me try and make this one look neat. 248. Then of course this thing here, this 298 is supposed to cross and come this way. When it crosses the equal signs, it becomes a negative the other side, so it becomes minus 298. So this here we have, what we have here is 72 minus 82. What do we have? So what we have here is negative 10x is going to give us 248 right here. So we have 248 minus 298. We have negative 50. We divide both sides by negative 10, divide both sides by negative 10. This goes with that by 10 once, by 10 once. You remain with your value of x, giving you the negatives go, the zeros die. 5 divided by 1 is 5. So our value of x is 5. So now that our value of x is 5, when you go back up here, you realize that Roman 1, determine the value of x. We have been able to determine the value of x. Okay, then Roman 2, find the value of Elijah's weighted mean. Now since we have the value of x, now we can determine Elijah's weighted mean. Okay, so that is more like part B. Let me just put it here. Okay, part B, Elijah's weighted mean. If you look at up here from our calculations, this is Elijah's weighted mean. We ended up with this expression for Elijah's weighted mean. So it's a matter of substituting for the value of x in this to get Elijah's weighted mean. Okay, so Elijah's weighted mean here we shall simply say Elijah's weighted mean is going to be equal to that expression, which is 298 plus 72x. Divide that by 5 plus x. So we have 298 plus 72 times our value of x, which is 5. So we shall say times 5. Divide that by 5 plus our value of x, which is also 5. So what we have as our final answer is Elijah's weighted mean, which is 65.8. So we have gotten the answer to that. We have finished. If you look up here, of course, after doing a question, you check to see if you have adequately answered it. We answered Roman 1, which required us to find the value of x. We've also done Roman 2, which required us to find Elijah's weighted mean. We've gotten our full marks, so now it's time for us to move to the next question. Okay, we have here our next question. It says that a researcher was interested in comparing, the students' performance in business mathematics and statistics. Okay, so we have business mathematics here, we have statistics. In order to determine the performance, he administered a quiz containing section A, which is business mathematics, and section B, which is statistics, and the maximum score for each section was 20 marks. Okay, so the results obtained were summarized in a frequency distribution table below. So what you're seeing here is we have marks in statistics and then marks in mathematics. Okay, you realize that this portion, the classes here are the same classes right there. This is more like a table that has been presented 2 in 1. Okay, however, here we have the marks in mathematics. These are the number of students, because they're telling us that this is a frequency distribution. So the marks are the classes 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20. Those are the marks that were obtained. And now when they're telling us that this is a frequency distribution table, it means that for between people who earned 0 to 4 marks, here we have 1. Here we have 1 person. Okay, 0 to 4, that is for in statistics. Then those who earned 4 to 8, these are the marks in statistics. Okay, like that. I think you get the interpretation of the table. So what we are trying to mean here is the way this thing is structured. Marks in statistics, those who got 0 to 4, we have 1, 2, 3, 4. There are 4 people here. Okay, those who got between 4 to 8 marks in statistics, we have 4 plus 1, 5, that is 10, 11, 12. There are 12 people here. Those who got between 8 to 12 in statistics, we have, that is 6 plus 4 is 10, 12, 13, 14 people. Then those who got between 12 to 16, 3, 4, 6, that's 11 people. Then those who got 16 to 20 marks are 9 people, that is 5 plus 3, 8 plus 1, 9. That is as far as statistics marks are concerned. Okay, then those who got marks in math. Okay, those who got marks in math, let me try and do this instead, just to use different colors to avoid confusion. Okay, those who got marks in mathematics, the way this table has been structured, this for math and mathematics, those who got between 0 and 4 are 1, 2, 3, so there are 3. Those who got between 4 to 8 is 4, 5, 6, 7, 8 people. Those who got between 8 and 12 marks is 5, 9, 10, 11. These are 15 people. This is 6, 7, 8, 9. These are 14 people, and then these are 5, 10. 5 plus 3, 8, 9, 10. Like, these are the classes. Those who got between 12 to 16, 16 to 20, these are the marks for math. Okay. Determine the section that had a higher spread of marks. Okay, up here I was just trying to summarize the table a bit. Determine the section which had better spread. Now, what parameter are we going to use to determine spread of marks? I think by better spread, which section had better spread? Now, by spread of marks, definitely here they are indirectly talking about which one, the marks that are spread. Let's say, let me try and explain this thing like this. So let's say we have, we have a bull's eye. Okay, darts. Okay, yeah, we do know darts. That is the bull's eye. You're trying to throw, arrows. Okay, and then as you're throwing arrows to the bull's eye, some arrows drop here, drop here, drop here, drop here, drop here, drop here. Then you can do the same thing. You have a bull's eye. You're trying to hit the middle target. This one is the middle target. But as you're trying to hit the middle target, as you're throwing your arrows, some drop here, others, another drops here, another drop here, others drop here, drop here. In other words, you're hitting far away from the target here. The targets here are closer, okay? Are closer to the targets. These ones are far apart. They are distributed. They are more spread. These ones are more spread. Okay, the targets here are more spread. Here, these ones are closer to the bull's eye. They are closer to the center. So what does that mean? This one that has more spread and this one are closer. How do we determine if we had this kind of in a statistical language? How do we determine the spread? We are going to determine the spread using a parameter called, we are going to call it standard deviation. Okay. So if we are to calculate the standard deviation, it would mean that if we are to get the standard deviation of this and the standard deviation of that, it would mean this standard deviation here will be higher than this one. This one will be lower. Okay, if you're to compare the two, you'll find that maybe the standard deviation of this maybe, let's say, is 2. The standard deviation here maybe is 6. Now, the interpretation of this means that the standard deviation here shows that this is more spread. The results, the targets are more spread from the bull's eye compared to that. I think you get what I mean. The standard deviation is just the measure of just how much data is spread away from the mean. And so if you're to compare the two standard deviations, you're able to determine which one is more spread away from the mean from the other. So if you are to use that analogy, this is just an illustration. I'm just trying to help you understand the question. Here, when they come and tell you that determine which section has better spread of marks, I think by the word better, they mean which one is more, Okay, what do we mean by better? Maybe they used the vague word here, better. Maybe they should have said determine which section had more spread or little spread, because better spread of marks, should we say better spread of marks means marks are supposed to be near each other? Or what is the definition of better spread? Does better spread mean they are far away from each other? I think the better spread means marks that are more far away from the mean mark. That is a better spread, okay? But in other words, what I'm trying to show you here is that the interpretation of this is that standard deviation is the thing here. So we are going to look for the standard deviation to determine how marks are spread regarding statistics. Then we are going to find the standard deviation to determine how the marks are spread in mathematics. So we are going to compare those two standard deviations, and then we shall be able to determine which we shall be able to conclude according to the question here. The question says determine which section had better spread of marks. So I think here this word is really vague. They meant better. Maybe they should have just said bigger spread. Okay, a bigger spread of marks or a wider spread, something like that. But anyway, we've gotten what the question requires, so let's get started. Now, when we are talking about statistical related numbers like these, normally there are formulas attached to them. Again, I am not going to go into the derivation of those formulas. Those will be top videos I'll do when we are covering the syllabus. Okay, so but in most examinations, you normally move into the examination room with they give you those formula booklets, and so when we come here, standard deviation, this is the formula for standard deviation. Okay, so you're just going to go and copy the formula, and you know, after copying the formula, you simply substitute. So the formula for standard deviation here, let me do it here, because we're going to look at the standard deviation for both. So the standard deviation is simply the square root of the variance. So the variance is given by summation of f of x squared, divide that by the summation of the f, which is the frequency, minus, in brackets, this minus the mean. Okay, summation of mean is f of x given by summation over f. In other words, total frequency times the variables divided by total frequency. This is squared, and of course all this thing is under a square root. Now it is going to be that, like, our columns, the columns that we are going to draw are going to be dictated by what is in our formula. So of course, as far as frequency distribution is concerned, we are going to get started with our classes, which are already here. Let's start with statistics. Okay, statistics. So as we get started with our statistics class, we have our classes, and then we have our classes for statistics. We have our value of the value of x. Of course, we are getting the columns. What columns are we supposed to consider? We are supposed to consider the columns as we see them appear in the formula. So in the formula, we have our classes, our value of x, which I'm going to discuss later. Then we have our frequency, which is our value of f. Okay, that is our frequency. Then of course, if you look at this formula, we are going to need our x squared. So I'll come here. We are going to need x squared. We are going to need the product of f times x. Okay, let's get started with the thing for mean. We have f times x. We are going to need that figure. Then also we are going to need the value of x squared right there. So we're going to do that, x squared. Then also we are going to need f times x squared. Okay, so we are going to need also f times x squared, the summation, like that. So that is for statistics. Okay, so what are our classes here for statistics? We have 0 to 4 right there. Then we have 4 to 8. You realize that these ones are class boundaries. Again, those dynamics of class boundaries, by the time you are watching this video, I am assuming that these things were introduced to you. How we find the mean, what are class boundaries, what are class intervals, how we are going to get this value of x. Here we are just doing revision of something that was already introduced to you in class. If you're looking at these things for the first time without lessons, I think it is not wise. 8 to 12, some of these things need to be introduced to you so that you understand where they come from, and that is something that I'm not going to do in this revision series. That is 12 to 16 is another class. Okay, then 16 to 20, like that. So those are our classes right there. Okay, and we are going to be drawing our totals down here like that. So that is as far as statistics is concerned. Okay, So let's do for mathematics as well, and then we just start filling in figures. So because we want to find we need to find these things. Okay, so let's do this for maths. Okay, so because mathematics, let me do this here. Okay, so mathematics, let's do our table for mathematics here. It's going to be pretty much the same as this one. So we begin with our classes. Okay, then we have our value of x. Okay, then we have our value, the frequency, f times x. We are doing f times x because it's required in the formula up here, f times x. Okay, then we shall also do x squared because it's in the formula. Then we also need f times x squared, like that. Then of course our classes here have 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20. And of course here also we have we shall be doing our formulas, our totals down there. Okay, so those are the two tables. So after determining our columns, we have determined our columns from our formula up here, what we need. So let's get started. So determining our value of x here is going to determine how we'd find it. It's going to determine whether we've been given class boundaries and class limits. I think again you must be knowing the difference. This what ends here is what starts here. 4 to 8, the last digit here is the first digit here. So these ones are class boundaries. But then there's such a thing we call class limits. If we are having class limits, you know, the upper class limit and the lower class limit, the way we get the value of x here will be different from when it is what? It is class boundaries. It's different. I will not go into those details now. So let's get started. So what we do here, we are simply going to, there are many ways of getting it. We can say the upper class boundary minus the lower class boundary divided by 2, and we add the answer to the lower class boundary. So it is 4 minus 0, which is 0. 4 minus 0, which is 4, divided by 2, it's 2. So we add the 2 to the lower class boundary, which gives us our value of x here as 2. Same here, 8 minus 4 is 4. What is 4 divided by 2? It is 2. We add the 2 to the lower class boundary, so 4 plus 2, which is 6. Come here, 12 minus 8 is 4. So 12 minus 8 is 4. What is that? 4 divided by 2, you get 2. So we add the 2 to the 8. We end up with 10. Come down here, 16 minus 12 is 4. What is 4 divided by 2? That is going to give us 2. We add the 2 to the lower class boundary here. 12 plus 2, which is giving us 14. 20 minus 16 is 4. What is 4 divided by 2? It is 2. So 2 plus the lower class boundary here, it's going to be what? 18. So those are our values of x right there. And of course our values of x here, it's going to be the same here. 2, 6, 10, 14, 18. Now these ones are classes that have the class intervals are the same. Okay, and again the approach is different when we are dealing with class limits. If we had class limits instead of class boundaries, we will discuss that later on. Okay, so now let's look at the frequency. So between 0 and 4, how many here for statistics? So let's get back to our table up here and start filling it here very fast. So for statistics, remember our statistics are these ones here. So between 0 and 4, I think we had already done them here. We have 4, 12, 14, that and that. Okay, we had already added the number of students. For those that got between 0 and 4, the number of students are 2, 3, 4. They are already 4. We had already done that in the beginning. So we could as well say these ones are 4, okay, for statistics. Then these ones are 12 right here. Those ones between 4 to 8, if you are to add up these ones, they are 12. So that is 12. Between 8 and 12, they are 14. So these are 14. So like that, 14, 11, 9. Okay, 11, 9. I hope I've not left anyone behind. Those are the frequencies. Okay. Can we do the same for math? We're doing these things concurrently. And that this is information we are picking from the table. So for mathematics, those are between 0 and 4. If you come here, up here, those between 0 and 4, they are 3. We already added them here. They are 3. So we shall come here, 0 and 4. We do 3. Then those between 4 and 8, for marks in mathematics, we added them here, 4, 5, 6, 7, 8. We already added it here as 8. So we shall come here, and these ones are 8. So the same here, 8 to 12, they are 15. So we come down here and say they are 15. Okay, so the rest is going to be, then they are 14, then they are 10. The ones for 12 to 16, they are 14. These ones are 10, like that. So we have, but basically we have just copied the frequency tables for statistics and mathematics. So now the rest of the work is just computational. We are trying to compute what is f times x. So here we do calculator business to fill in the remaining tables. Okay, so f 4 times 2 here is 8. Okay, that is as far as we are dealing at the statistics. 6 times 12 is 72. Then this is going to be 14 times 10 is 140. Then, because this is f and x, 11 times 14 is 154. Then this is 162. X squared, we are looking at 2 squared. X squared here is 4. This is 36. This is 100. That is 10 squared. Then 14 squared is 196. Then definitely here we have 18 squared, which is 324. It's very easy for you to make an error. Here it is very important that you tread carefully. You fill in these things carefully. It's very easy to make an arithmetic error as you're punching in your calculator. So fx squared, so we are getting our column of f, and we are multiplying it by x squared. So here it's 4 times 4, which is 16. Then here we have our f, which is 12 times 36, which is 432. Okay. Then we have f times x squared, 14 times 100, which is 1400. Then we have 11 times 196. 11 times 196 giving us 2156. Then of course lastly, this is going to be our f, which is 9 times x squared, which is 324, is going to give us 2916, like that. Okay, so basically it's just arithmetic. So we're going to do the same for this mathematics thing here. Okay, so again, I'm just going to do this faster. I think we all get what we do. So again, remember, now we finished filling in all the tables. Remember, when we are trying to find the totals, of course, our totals here are going to be determined by our formula. So in our formula for standard deviation, we are going to need summation of f, f of x squared, as you see here, f of x squared, which is this thing here, okay? We need the summation of f of x squared, so we are going to need that total. So we are going to go ahead and add it. F of x squared here, for statistics, it's going to be 6,920 after adding this column. That is summation of then we have summation of f, which is right here. And what is summation of f? It is 50. This is our summation of f. So we're going to need also summation of fx, summation of fx here. When we add our summation of fx here, we are going to end up with 536. This is our summation of fx right there. Then what else? Yeah, that's it. So we are going to do the same totals this way, okay? Here in our value of x, a summation of f, definitely it's already 50 here, okay? Then this is going to summation of f of x. Our summation of f of x here is 580. Then we have our summation of fx squared right there. It's going to give us 7,784, like that. This summation of fx squared, yep, like that. So I think we have it. So now we can go ahead and find the standard deviations for both, okay, statistics and mathematics. It's now that we have put the things in our formulas, it's a matter of just, substitution, and we get our answers. Okay, so our standard deviation for statistics, of course, it's going to be summation of f of x squared over the summation of the frequency minus the mean squared, okay? Minus the mean squared under the square root. So what do we have here? What we have here is going to become under the square root. Of course, what is f of this summation of f of x squared is this up here. So we're just substituting figures here, right? So this is going to become 6,920. Divide that by summation of f, which is 50, minus the mean squared. This is going to be 536. Divide that by 50. Summation of f of x here is 536. Then summation of f is 50 squared. So what do we have at the end of the day? All this is under the square root. Of course, if you punch that into your calculator, you're going to end up with 4.8458, like that. That is as far as standard deviation for statistics is concerned. Now let's do standard deviation, okay? Standard deviation for math. So for standard deviation for math, again, we are going to substitute into that formula. Summation of f of x squared, divide that by summation of f minus the mean squared, which is summation of f of x over summation of f, okay? So what do we have here? Summation of f of x squared, if you come here, up here on our table here, it's going to be this 7,000, this summation of f of x squared, so it is 7,784. Divide that by summation of f, which is up here, which is just 50, minus the mean squared. The mean here is summation of f of x, which is 580 right there. 580, divide that by summation of f, which is 50. This is squared, and this whole thing is under the square root. So what we end up here is 4.5957. So after ending up with that, then you let's get back to the question. We have found the two, the standard deviations of the two. So which one has a better spread? So you will find that the standard deviation for statistics is 4.8, okay? The one for math is 4.5. So this one has a higher spread. In other words, this figure 4.8, it's just giving us the measure to which this data is spread away from the mean. Okay, so if you come back up to they're asking us determine which section has better spread. Of course, here the one that has better spread is statistics. So we shall conclude and say that statistics are the data that has the statistics. Okay, which section has better spread of marks? The statistics marks have a better spread. So that's how we shall conclude. We shall simply say statistics marks have a better, they have a better spread. So that's it. We will have answered our question. We have answered our 2 questions. So this brings us to the end of this video. Thanks for watching. If you have any questions, of course, feel free to let me know in the comment section below. I'll catch you in the next revision video. My name is Arnold Kisembo Rangakuramia, and thanks for watching.